Okay. So we'll kind of talk through this stuff, and then your 1-2 Math Excel is due tonight as a reminder, and then also your virtual scavenger hunt. Whatever you were able to complete on it, submit that virtual scavenger hunt. And if there's a part you can't complete, like Stark State or something, just make a note on that slide waiting for this from Stark State. But make sure you do everything that you can on the slides, and then I'll at least know the part that you can't get to, and we can figure it out in the meantime, okay? All right, so you should, on your gold paper from yesterday, have all the definitions for 1-3 written down. So we're just going to kind of quickly go through those, bless you. If you need me to go slower or pause at any point in time, feel free to do that. But we're just going to kind of talk about what all this stuff means. So we talked about already in an earlier section about what's a population and what's a sample and what's a parameter and what's a statistic. That's going to be the first step in if we're designing a statistical study, which is like our ultimate goal of this in the next chapter. Getting a statistical study, collecting that data, and eventually starting to do some calculations with it. This next section, 1-3, is about how to develop a plan and how we're going to collect the data, not the data itself. Okay, so the first set of definitions is an observational study versus an experiment. An observational study is when the researcher does not affect the outcome in any way. They simply observe or they simply ask questions, but they're not changing the outcome in any way. Whereas an experiment, the researcher is applying what we call a treatment, and then they're looking to see how does that treatment affect whoever they are choosing to be part of their population or sample. So typically how an experiment works is you have what we call a treatment group and a control group. A treatment group is a group that gets a treatment of some kind. It could be like a blood pressure medication that's being tested. It could be a movie that they're previewing to get reviews on. So lots of different, it could be a sample of a menu, a food item. So the treatment could be anything. A control group is a group that does not receive the treatment. Or it receives something that is similar but not new. So maybe if they're testing a new menu item, the control group will receive the menu item that's already on the menu, and the treatment group would receive the new menu item, and then they would compare the two groups, okay? Often, a control group is given something called a placebo. A placebo is often used when we talk about like testing for medications. So if I made two groups out of this classroom and I gave half of you a pill and the other half I did not, and I wanted to see how that affected your blood pressure, maybe your blood pressure would change just because you thought you were receiving a treatment. So a way to combat that is we give half of the group the actual medication and the other half of the group a false medication, like a sugar pill, something that wouldn't really affect their blood pressure, but that way both groups have the mentality that they are receiving a treatment that could help them. Now, when we receive those treatments, there's another definition down here somewhere. Maybe not. I have it on there or not? Sorry. No, maybe not. You don't need to do that. Never mind. Okay. All right, so let's talk about these real quick. Observational study versus experiment. So the first one, researchers study the effect of vitamin D3 supplementation on patients with an antibody deficiency or frequent respiratory tract infections. To perform this study, 70 patients received 4,000 units of vitamin D for a year. Another group of 70 patients receive a placebo daily for a year. Is that an experiment or an observational study? Okay, so that's an experiment. So we're dividing into groups. We have a treatment group, we have a control group, and the researcher is affecting the outcome of the survey or the research. The bottom one says, researchers conduct a study to determine how confident Americans are in the U.S. economy. To perform the study, researchers called 3,040 U.S. adults and asked them to rate current U.S. economic conditions and whether the U.S. economy is getting better or worse. Is that an observational study or an experiment? That's an observational study. They're simply asking a question and getting the answer. Okay, a simulation is a mathematical model or a physical model that reproduces conditions. So a common example of that is like crash test dummies. Crash test dummies are used to simulate what would happen to a body in a car crash, and then they determine safety features of vehicles based on that. So it allows you to study situations that are impractical. So you can imagine we would not want to put an actual person into a crash test because that would be dangerous and impractical and life-threatening. So that's why we use crash test dummies in that situation, okay? We want to be able to simulate certain things, though, because we still want to be able to study them. Survey, you know what that is. We're just going to jump right past that. Okay. When we start designing experiments, there's going to be 4 key factors that we look for. Control, randomization, sample size, and then being able to replicate the experiment. It's important that you do all 4 of these because we want to produce meaningful, unbiased results. Meaningful means we want it to mean something. We want it to answer the question that's being asked. And unbiased means we don't want our answer or our results skewed in any direction because of the questioning or the research method or the sample that we chose to use. Okay. So the first thing we talk about with control is confounding variables. A confounding variable is something that's not directly related to an experiment, but it affects the outcome of the experiment. For example, if I were conducting a survey about satisfaction of school lunches, and I chose to survey only people in 4th period, my results might be better than people that I surveyed in 7th period, or they might be worse because maybe in 4th period people aren't as hungry yet, or in 7th period they are as hungry. So this hunger factor based on who I'm asking and when they eat lunch, or maybe how warm the lunch is, or it's been cooked 2 hours ago versus it's fresh, things like that are confounding variables that could affect the outcome of my survey that I have to think about. Okay, we obviously want as few confounding variables as possible. Oh, there's a definition I was looking for earlier, because we want to make sure the results we're getting are directly related to the question that's being asked. Placebo effect. A placebo effect is when something changes, but somebody received a placebo as their treatment, like that blood pressure example I gave you. Maybe you received the placebo dose, but your blood pressure improved. It improved because of your mental state. You thought you were receiving treatment, and therefore your blood pressure improved. What we want is we want to minimize a placebo effect if we can, and how we do that is with blinding or double blinding. Blinding is when the subject does not know if they are receiving the placebo or the actual treatment. Double blind is when both the experimenter and the subject do not know if they're receiving the placebo or the treatment. Because if I'm a researcher and I know that you are receiving the placebo, my mannerisms or my tone of voice or the way I ask the question could release that information to you, or it could skew a question a certain way. So the researcher not knowing who has what treatment can also be useful and provide more valid results. Okay. Randomization is the process of randomly assigning subjects to different treatment groups. Do you guys know how to do that on your calculator? No? Do you guys have your calculator? I can show you real quick. This is how I do the cell phone lotto every day. If you hit math, which buttons is it? And then you go over to probability. And then I usually use number 8, which is random integer, no repeats. But you could just choose random integer if you're okay with numbers repeating. And then you choose a lower, an upper, so those are the bottom and the top. So like 1 and 18 I would pick for our cell phone lotto. And then N is your sample size that you're choosing. We're going to use N a lot this semester. So for the cell phone lotto, I always pick 1, but you could pick like 5 if you want your calculator to spit out 5 different random integers between 1 and 18. And then you hit paste, and it will do that for you. Okay. So that's a quick way to get random numbers. There's lots of generators online too that you can just Google random number generator, and we'll just throw sets of numbers at you too, if you want.
So it asks you like your lower number. It asks you what lower.
Oh, yours looks like that. So it's the older version. I think you can just type 1,18 like that. There you go. Everybody find that okay? Okay, so it's a good way to generate a random list of numbers if you want to. Okay, so the next couple of slides are about different ways that you can design an experiment and how we know who's going to get that treatment and who's going to get the control, maybe a placebo. So the first type of experiment design is called randomized block design, where we take all of the subjects, and this is a nice little graphic if you wanted to put an example of this on your gold paper. All subjects, and then we divide them into some sort of groups based on a similarity. So in this picture, they're dividing them by age. So we've got people in their 30s, people in their 40s, people in their 50s. And then within each group, maybe a random sample of people is given the control, and a random sample of people is given the treatment. Okay, and that ensures that we've got different people from each category that we can include in our results, which again makes it a more valid experiment for us. Okay, so it doesn't have to be age, it could be, it could be gender, it could be grade level. There's a lot of different things that you could use to create those blocks, but then within each block, we split the block in half get one and half get the other, and you could do that randomly, and there's other ways we'll talk about that as well. Okay, so that's a randomized block design. The next one is similar. Think of it on a smaller scale though. So instead of taking a whole block of people, which could be 100 people, 1,000 people, and dividing half to the control and half to the treatment, they match them up in pairs. So two individuals go together, and the way they could pair them up, a common example is like twins, people that share the same genetic makeup. They're going to take two twins, and they're going to give one twin the control and one twin the treatment. And then they can see, because they have identical genetic makeup, how is that truly affecting that person, okay? So that would be a common example of matched pair design. We pick two people, one gets a treatment, one gets a control. All right, sample size. So sample size, we're going to talk a lot about this semester. You don't want it to be too big. You don't want it to be too big because it's difficult to collect that data. It could be wasteful. It could be costly. But you also don't want it to be too small. Like if I have a survey and I only ask 3 people, am I going to get very valid results? Probably not, right? Or if I design a survey and I want to survey 2,000 people, that's a huge undertaking to do, and it's a lot of data to collect. So we want to kind of find a happy medium. One thing that we'll talk about in later chapters is kind of like nice little rule of thumb if you want to put it somewhere, is n is going to represent our sample size. We want n typically to be bigger than 30 at least. And if it's not bigger than 30, then we're going to want some other factors to come into play to ensure that we're going to get valid results. So that's going to be kind of like a nice rule of thumb. If you want a sample size that's decent and going to give you good results, you want to make sure that sample is at least bigger than 30. Okay. All right. Replication. We want to be able to replicate an experiment. Let's say I get results that this blood pressure medication is working. Great. But then I replicate the experiment, and all of a sudden my results say it doesn't work. Is that a good result? No. Can I really take into account what I got the first time around and use that and publicize it? Probably not. We want to be able to replicate the same results over and over again to ensure validity. So replication is going to be really important for us in statistics as well. All right. So I'm going to have you guys work in maybe little groups for this. So we talked a little bit about experiment design. Here, a company wants to test the effectiveness of a new gum developed to help people quit smoking. In each of these experiment designs, there is some sort of problem. I want you to identify the problem and figure out a way that you could fix the problem to potentially provide more valid results from that experiment. Okay? So my groups, let's do groups of like 4, maybe like you 4 right here, you 4 back there. My 4 singletons, Evan's gonna wake up. There we go, 4 right here, and then 4 right there. All right. into the group. There we go. Find the problem with the experiment and figure out a better way to design it. You're working with that group right there. Ready? Discuss. Okay, so in the first one, 10 people, 5 are given the gum, 5 are given the placebo. After 2 months, the 5 that had the gum quit smoking. What's wrong with that?
10 is too small.
10 is too small. It could have been completely coincidence that those 5 people were motivated to quit smoking. Yes?
The length of the experiment is too short.
Length of the experiment potentially also. Maybe it's a lot easier after 2 months to quit versus a year, a long-term experiment. Good. Anything else? I'll take it. Okay, next one. Company identifies 1,000 adults. Now it's a little bigger. The subjects are divided into blocks according to gender. Female are given the gum. Males are given the placebo. After 2 months, a significant number of the females have quit smoking.
It could have different effects based on gender, so you have to do it more randomly.
Good. So they divide them into blocks, male, female, and then what should happen in each of those blocks? Go ahead.
They should be divided among the control group and the treatment group.
Perfect. So like half the males, however they decide, should receive the control, and half of the non-working gum, the placebo, and then the other half should receive the gum that they're testing out. Good. Okay. Company identifies 240 adults who are heavy smokers. The subjects are randomly assigned to be in a gum treatment group or a control group. Each subject is also given a DVD featuring the dangers of smoking. After 4 months, most of them in the treatment group have quit smoking. What's the problem? The problem is?
Yeah, it's like a new part of it.
There's a word for that. What's the word for it? Say confounding variable. There's a confounding variable here. So we don't know, is it the DVD? Is it the gum? Is it a combination of the two? So it's almost like this experiment needs several parts, or maybe 2 separate experiments. One with the DVD and one with the gum to see what truly will affect the outcome. Make sense? Great. Okay. You can stay where you are. We'll have one more thing you guys can do together. Okay, next, sampling techniques. If I can make that a little smaller. There we go. All right, so a census is where we survey, count, or measure the entire population. So you guys know there's a U.S. Census every 10 years. Do you think that they truly, in a census, have information about every single U.S. citizen, though? No, because there's people that get that email or that letter in the mail and they just throw it away. So census is very, very difficult to get. So usually we talk about sampling the population. Even the U.S. Census is really truly a sample. Sampling error is the difference between the results of your sample and what is happening in the full population. And of course, we want our error to be as small as possible. We don't want our sample to have a big difference in result from what we would get from the population as a whole. Random sampling, so the next last 5 definitions are going to be about different ways you can find a sample. The first one is a simple random sample. Simple random sample is when we just give everybody a number, we select numbers like we can on our TA84 calculator, and the numbers that are selected are the ones that are included in the sample. So very simple, okay? Then we get into these type of samples. So the next one is a stratified sample. This is very similar to the experimental block design, okay? So what we do is we take a group of people and we divide them by characteristic. In this graphic, they're dividing them by income, low income, middle income, and high income. And then with each group, they call them strata, we have a random sample from each group. So we ensure that a few people from each group are selected. A cluster sample is similar to this. We're divided into groups by some sort of similarity, but the only difference is instead of picking a few people from each group, in a cluster sample, we pick an entire group and survey everyone in that group. So if this was made into a cluster sample, I would divide everybody into low, middle, and high income, but then I would maybe only survey the people in middle income, and that would be the results of my survey. Okay. The last 2 are systematic and convenience. Systematic, we saw in an example in an earlier lesson, I think it was like third or sixth person that walked into the mall, do you remember that? As a systematic sample. Those people were naturally ordered in some way, and every sixth person was then interviewed. So that's systematic. And then finally, convenience sample. Convenience samples are bad. Convenience samples are really going to lead to a biased experiment in most cases, because you are only surveying people that are convenient. Like if I wanted to get a survey of Jackson High School students and I only surveyed people in this room, that would be literally the most convenient thing I can do, and it would probably give biased results about whatever question I was asking, because you're all seniors and you're all taking CCP classes and you're all planning to go to college somewhere because you're taking college classes. So there's a lot of similarities that you have that if I asked any questions related to any of those things, it would create a biased survey and not be a good representation of my population. Okay, so the last slide you guys can discuss with the groups. I've got 5 different sampling techniques here, and I want you to determine which of the 5 these are. So simple random, stratified, cluster, systematic, or convenience. Those are your options here. It's kind of like a multiple choice question. All right, so take a few minutes, talk about them, we'll put them on the board, and that'll wrap it up for us. All right, first one, you divide the student population with respect to majors and randomly select and question some students in each major. What is that? That is a stratified sample. Good, number 1. All right, you assign each student a number and generate random numbers. You then question each student whose number is randomly selected. That is?
Random.
Yes, and they're going to use the word simple random, but it is just straight random. Perfect. You select students who are in your biology class. That is a convenience sample. It's going to give us biased results. You select a class at random and question each student in that class. That is a cluster. So we're grouping people by class and selecting everyone within one class, within one group. And finally, you assign each student a number, and after choosing a starting number, question every 25th student. That is systematic. Good. Okay. So that gold paper in front of you is what your quiz is over on Tuesday. On Monday, we're going to review together. I've got some games we'll play. I have a Quizlet that I'll publish for you at the end of the period on Monday. You guys can use that to practice with Monday night. It's, essentially a set of flashcards, but if you want to make your own, you can always do that too. You're going to notice that a lot of the questions in Math Excel and what we're going to see on the quiz, it's pretty much just multiple choice for a lot of these. Is it a population or is it a sample? What type of sampling technique is it? That sort of thing. So as long as you know your definitions, if you can maybe off the top of your head give an example of what each thing would look like, you're pretty set for Tuesday. And then starting on Wednesday, we'll start doing some actual math. We'll have like some numbers and calculations and things like that. We're getting there. Okay. All right. So remember 1, 2 is due tonight. Your virtual scavenger hunt is due tonight. If you haven't submitted that, submit whatever you can, whatever you have done. And then 1, 3, this guy is going to be due on Monday night in Math Excel. All right? Great. Thanks, guys. Okay, I'll do cell phone lotto. And the last part of the period here is yours. 6. Nobody's paid.
Hey, what are you doing?
All right, you can grab your phone.